Let us discuss about fundamental principle of counting. We have two fundamental principles of counting, one for multiplication and the other one for addition. Let us first discuss about fundamental principle of multiplication. I will explain it with an example. Let us consider that we have two red balls, R1 and R2, and three blue balls, B1, B2 and B3. Now we have to select one red ball and one blue ball, and I'm using the word and in between. So I need one red ball and one blue ball. So in how many ways I can select one red ball and one blue ball? If I select R1 red ball, first red ball, I may select first blue ball or B2 or B3. So three ways are there. Or I may go for R2. If I select R2, I may select B1 or B2 or B3. So I have two choices to select one red ball, and I have three choices to select one blue ball. 2 into 3, totally 6 ways are there. Here I am selecting the red ball, so I have two choices. After I select, I can select one of the three blue balls, B1, B2, B3. Similarly, B1, B2, B3. So if I do the first selection, I will have R1 and B1, first red ball and first blue ball. Or if I select like this, I will have R1 and B2. Here I will have R1 and B3, or I may select R2 B1 or R2 B2 or R2 B3. So totally we have 6 ways. So this is fundamental principle of multiplication. So remember, if you use the word and, we multiply. Now see your textbook, page number 136. So fundamental principle of multiplication can be defined like this. If an event can occur in m different ways, the first event can occur in m different ways, following which another event can occur in n different ways, then the total number of occurrence of the events in the given order is m into n. So we may have three events also. For example, the first event can occur in m ways, the second can occur in n different ways, and the third one can occur in p different ways. So the total number of ways will be m into n into p. Now let us see what is fundamental principle of counting for addition. I will take the same example. I have two red balls. I will name them as R1 and R2. And I have three blue balls. Let us name them as B1, B2 and B3. Here I have to select one ball. It may be either red or blue. So I have to select only one ball here. So how many ways are there? So I am selecting one ball. So it may be R1 or R2, or it may be B1, B2 or B3. So how many ways I have? 5 ways. Here what are we doing? 2 plus 3. So we may select any one of those two red balls, so we have 2 ways, or we may select any one of those 3 blue balls, so 3 ways. So 2 plus 3. If we have or, we add. Now I can define the fundamental principle of addition as if there are two events that can occur independently in m and n different ways. The first one, m and n different ways, then either of the two events can occur in m plus n ways. This is fundamental principle of addition. So easy way to remember is, if you have the word and, multiply. If you have the word or, add. So remember this point, very important. We use this in permutation and combination as well as in probability. Now let's do exercise 7.1. Make a note of it in your textbook. On top of the page, write this: for and, multiplication; for or, addition. Now question number 1. How many 3-digit numbers can be formed from the digits 1, 2, 3, 4 and 5, assuming that repetition of the digits is allowed? So the first condition given in this question is you are going to form a 3-digit number. And then the second condition given in this question is you can make use of these 5 digits, 1, 2, 3, 4, 5. And the third condition is repetition of the digits is allowed. Repetition is allowed. This is the third condition given. Now let us use fundamental principle of counting. We have to form a 3-digit number. So I can fill up the ones place digit in any one of those 5 ways. I can use any one of these 5 digits. And tens place digit can be filled in with again any one of these 5 ways because repetition is allowed. And hundreds place digit is also having 5 ways. So number of ways for ones place digit is equal to 5. Number of ways for tens place digit, that is also 5 because repetition is allowed. Number of ways for hundreds place digit is equal to 5. Now we need all the 3 digits. I need ones place digit and tens place digit and hundreds place digit. So I need to multiply. Therefore, total number of ways is equal to 5 into 5 into 5, 125. So I can form 125 3-digit numbers using the given digits when repetition is allowed. See the second subdivision. Here again the first condition is we have to form a 3-digit number. And the second condition is we have to make use of these 5 digits only. And the third condition is repetition not allowed. Okay, now let us consider the ones place digit. I can fill up this ones place digit in any one of those 5 ways because 5 options I have. And then tens place digit, I have only 4 options, 4 choices, because I have already used 1 digit in ones place. So I have only 4 options left. So it can be filled in 4 ways. Now hundreds place digit can be filled in 3 ways. So number of ways for ones place digit is equal to 5. Number of ways for tens place digit is equal to 4 because repetition is not allowed. So number of ways for hundreds place digit is 3. Therefore, total number of ways is equal to 5 into 4 into 3, 60. Now question number 2. How many 3-digit even numbers can be formed from the digits 1, 2, 3, 4, 5, 6 if the digits can be repeated? So here the first condition given is you have to form a 3-digit number. The second condition is it should be an even number. And the third condition is you have to make use of these digits. And fourth condition is digits can be repeated. Repetition is allowed. So these are the 4 conditions given. So you have to keep in mind all these 4 conditions. So you have to form a 3-digit number and it should be an even number. So we decide whether the number is even or odd by looking at the last digit, units place digit. So to be an even number, it should end with 2, 4 or 6. So it has 3 ways. We can use one of these 3 digits, either 2 or 4 or 6. So we have 3 choices to fill up units place digit. Now the next one, tens place digit. Tens place digit we have 6 choices because repetition is allowed. And for hundreds place digit we have again 6 choices because repetition is allowed. So number of ways for ones place digit is equal to 3. Number of ways for tens place digit is equal to 6 because repetition is allowed. Then number of ways for hundreds place digit is equal to 6. So total number of ways is equal to we need all 3 digits. We need ones place digit and tens place digit and hundreds place digit. So we need to multiply. The answer is 36 times 3, 108. Question number 3. How many 4-letter code can be formed using the first 10 letters of the English alphabet if no letter can be repeated? Let us see the conditions given here. You have to form a 4-letter code. And the second condition given is using the first 10 alphabets. You can use first 10 letters. This is the next condition. And then if no letter can be repeated, repetition not allowed. We have to form a 4-letter code. So the first letter can be filled in 10 ways. Because 10 options we have. And the second place, this position can be filled in 9 ways. Because already you have used one letter in this position, we cannot repeat that same thing here. Because repetition is not allowed. And here 8 choices we have. For this position we have 7 choices. So first place can be filled in 10 ways. You may start from the last letter in this direction or in this direction, does not matter. The answer will be the same. Then the second place can be filled in 9 ways because repetition is not allowed here. The third place can be filled in 8 ways. And fourth place can be filled in 7 ways. Therefore, the total number of ways is equal to 10 into 9 into 8 into 7. 72 into 7. 504 and into 10 will give you 5040. So these many 4-letter codes can be formed using the first 10 letters of the English alphabet with no repetition. Question number 4. How many 5-digit telephone numbers can be constructed using the digits 0 to 9 if each number starts with 67 and no digit appears more than once? Let us see all the conditions which are given in the question. You have to form a 5-digit number. And the second condition given is can be constructed using the digits 0 to 9. 0 to 9 we have 10 digits. If each number starts with 67, each number starts with 6 and 7, 67. And fourth condition is no digit appears more than once. No repetition. We have to form a 5-digit telephone number. Now it starts with 67. So first 2 digits are 6 and 7. We don't have any choice for these 2 positions. So only one way to fill up, and here also only one way to fill up this position. And then let us think about this, the third digit. The third digit I can use 0 to 9 with no repeats. I cannot use 6 and 7 in this third position. So out of 10 digits available, already we have used 6 and 7. So we are left with 8 digits only now. So I have 8 choices. Now to fill up the fourth digit, fourth position, I have only 7 ways because repetition is not allowed. And to fill up the last position, I have only 6 ways. So let us write the answer. The first 2 digits are 6 and 7. Number of ways for the third digit is equal to 8 because repetition is not allowed. Out of 10 digits, already I have used 2 digits. Then number of ways for the fourth digit is equal to 7. Then number of ways for the fifth digit is equal to 6. So total number of ways, let us calculate. One into 1 into 8 into 7 into 6. 7 8s are 56. 56 into 6, which is 336. Question number 5. A coin is tossed 3 times and the outcomes are recorded. how many possible outcomes are there. So we have 3 coins. Here the outcome may be head or tail. 2 ways are there. For this coin, 2 ways, again head or tail. This also has 2 ways. For each coin we have 2 choices, 2 ways we have, 2 outcomes we have. So the total number of ways will be 2 into 2 into 2. Why are we multiplying? Because we need the result of the first coin as well as the second coin and the third coin also. So we need to multiply because it is and. So total number of ways is equal to 8. Question number 6. Given 5 flags of different colors, how many different signals can be generated if each signal requires the use of 2 flags, one below the other? You have 5 different colors. So we have these 5 colors, say. Now you have to form a signal using 2 colors, one below the other. So I can fill up this first position by any one of these 5 colors. I have 5 choices. Now I have used one of the colors. For example, I have used the red color, say. Now I have only 4 leftover colors, so I may use any one of those 4. Therefore, total number of ways will be 5 into 4. So number of ways for first position is equal to 5. Number of ways for the second position in the flag is equal to 4 because I have 5 pieces. I cannot use the same color again. I have only one piece of each color. Therefore, total number of ways is equal to 5 times 4, which is 20. Now see example 1. Find the number of 4-letter words with or without meaning which can be formed out of the letters of the word rose, where the repetition of letters is not allowed. So you have to form a 4-letter word and repetition not allowed. These are the 2 conditions given. So this can be filled up in 4 ways. No repetition, so 3, 2 and 1. Number of ways for the first place is equal to 4. Number of ways for the second place is equal to 3. And number of ways for the third place is equal to 2. And for the fourth place it is 1. Write the whole sentences. Therefore, total number of ways is equal to I need all 4 positions. First one and second one and third and fourth. So I need to multiply. So totally we can form 24 words with meaning or without meaning. Example 2. Given 4 flags of different colors, how many different signals can be generated if a signal requires the use of 2 flags, one below the other? We did a similar question in the exercise. So 4 different colors are given. So these are the 4 colors given. So the first place can be filled up in 4 ways. We have only one piece of each color. So this can be filled in
3 ways.
So number of ways for the first position is equal to 4. So number of ways of the second position is equal to 3. So total number of ways is equal to 4 times 3, 12. So we can form 12 signals with 2 different colors, one below the other. Example 3. How many 2-digit even numbers? So the first condition is we have to form a 2-digit number. And the second condition is it should be an even number. Can be formed from the digits. The third condition is we can make use of these digits if the digits can be repeated. Repetition is allowed. Okay, these are the 4 conditions given in the question. We have to form a 2-digit number. It should be an even number. So we decide whether the number is even or odd by looking at the ones place digit. So if a condition is given for a certain position, fill up that position first. We have a condition for units placed. So fill up that position first. So even number, it should end with either 2 or 4. We have only 2 ways to fill up this. Now let us think about the tens place digit. Repetition is allowed. So we have 5 choices here because we can repeat the digit which we have used in the units place. So number of ways for ones place digit is equal to 2, and number of ways for tens place digit is equal to 5 because repetition is allowed. Therefore, total number of ways is equal to 2 5s are 10. We need units place digit and tenths place digit. Since we use the word and here, we need to multiply. So we can form 10 even 2-digit numbers using the given digits and repetition allowed. Example 4. Find the number of different signals that can be generated by arranging at least 2 flags in order one below the other on a vertical staff if 5 different flags are available. The word at least is very important. Underline that word in the textbook. What do you mean by at least? Minimum 2 flags. Minimum 2 flags means we may have 2 flags or 3 flags or 4 flags, or we may use all 5 flags. 5 colors are available. Now let us consider the first case using 2 colors. So the first position can be filled in 5 ways, the second one in 4 ways. Because one color we have used, we will have remaining 4 colors to use in the second position. Therefore, total number of ways is 5 4s are 20. Now the second case, using 3 flags. So this can be filled up in 5 ways, then 4, then 3. So total number of ways will be 5, times 4 times 3, 60 ways. Let us consider using 4 flags. So this can be filled in 5 ways, this in 4 ways, this position in 3 ways, and this in 2 ways. So 5 multiplied with 4 and 3 and 2. 20 into 6, 120 ways. So we can form 120 signals using 4 colors. Then next, using 5 flags. So number of choices for the first position is 5, then for the second 4, then 3, then 2 and 1. So the answer is the same, 120. Therefore, the total number of signals is equal to we have to add these answers. Why are we adding? Because we can form with 2 flags or 3 flags or 4 flags or 5 flags. If we use the word or, we should add. So 20 plus 60 plus 120 plus 120. The total is 240, 300, 320. Let us learn about factorials. So factorial notation is this exclamatory mark. N factorial means you have to multiply all natural numbers till n. 1 into 2 into 3 into 4 into up to n. We can find factorial of positive integers. So 1 factorial is 1. 2 factorial is 1 into 2, which is 2. 3 factorial is 1 into 2 into 3, which is 6. 4 factorial is 1 into 2, 3 multiplied by 4, 24, etc. Now 0 factorial is 1. So you have to memorize this. 0 factorial is 1. It is not 0. 1 factorial is also 1. Now let us see how 0 factorial is 1. 4 factorial, I can write it as 5 factorial divided by 5. 1, 2, 3, 4, 5 divided by 5, which gives you 4 factorial. Similarly, I can write 3 factorial as 4 factorial by 4. 2 factorial is 3 factorial divided by 3. 1 factorial is 2 factorial divided by 2. And 0 factorial is 1 factorial by 1, which is 1 by 1, 1. Therefore, remember that 0 factorial is 1. Now let us do exercise 7.2. This is a very simple exercise. We need to learn about factorials because in permutation and combination formulae we are going to use factorials. Actually, factorial of any number can be calculated. For fractions also we can calculate, but we don't have it in our syllabus. We can find factorials of only natural numbers. Only for natural numbers we are going to use factorials in our syllabus. First question, evaluate 8 factorial. 8 factorial is 1 multiplied by 2, 3, 4, 5, 6, 7, 8. You have to multiply all natural numbers till 8 for 8 factorial. And the answer is 40320. Then the second subdivision, 4 factorial minus 3 factorial. 4 factorial is 1 multiplied by 2 multiplied by 3 multiplied by 4 minus 3 factorial is 1 multiplied by 2 and multiplied by 3. This is 24 and that is 6. 24 minus 6 is 18. So 4 factorial minus 3 factorial should not be written as 1 factorial. You have to find their factorials and then subtract. You should not subtract the numbers first and then find the factorials. Second question, is 3 factorial plus 4 factorial equal to 7 factorial? Let us find the left hand side. 3 factorial is 6, 4 factorial is 24, so the left hand side is 30. But 7 factorial is 5040. So they are not the same. 3 factorial plus 4 factorial is not equal to 7 factorial. Third question, compute 8 factorial divided by 6 factorial times 2 factorial. I can write this 8 factorial as 8 into 7 into 6 factorial, so that I can cancel 6 factorial and 2 factorial is 2. The answer is 28. Question 4. 1 divided by 6 factorial plus 1 divided by 7 factorial is equal to x divided by 8 factorial. Find x. 1 by 6 factorial. Let us write 7 factorial as 7 times 6 factorial. Similarly, 8 factorial can be written as 8 times 7 times 6 factorial, so that I can cancel 6 factorial throughout. 1 plus 1 by 7 is equal to x by 8 times 7. Take LCM. 7 plus 1, 8 by 7 is equal to x by 8 times 7. X is 8 8s are 64. Question 5. Evaluate n factorial divided by n minus r factorial when n is equal to 6 and r is equal to 2. Let us plug in these values. So we will get 6 factorial divided by 6 minus 2, 4 factorial. 6 factorial may be split and written as 6 into 5 into 4 factorial divided by 4 factorial. 6 5s are 30. The second subdivision, n is 9 and r is 5. We get 9 factorial divided by 9 minus 5 factorial, which is 4 factorial. Let us write 9 factorial as 9 times 8 times 7 times 6, 5 times 4 factorial divided by 4 factorial. Let us multiply and write 72 into 7 into 3. The answer is 15120.